Today we are going to talk about structures in Solidity. What is a struct in Solidity? We will begin with what is a struct in Solidity. Structs are custom defined types that can group several types together. Structs are custom defined types that can group several types together. Let us take a look at an example. On the left side of the screen you can see here we have defined a struct to do and it has several different types. First type is string and second type is boolean. So this is what a structure does. It combines several types together, or you can name it as a custom defined user type. What is a memory model? To remember, how can we declare or define a struct? The memory model to remember of defining or declaring a struct is use the keyword struct followed by the name of the structure, then opening curly braces, followed by the different members of the structure, and at last you have the closing curly braces. Let us look at an example. On the left side of the screen, we have defined a struct to do. This is the name of the structure. Here it is the keyword struct. And here we have the different members of the structure. This is how you must remember of declaring or defining a structure. Going forward, we will look into how can we initialize a structure in Solidity. There are three ways using which you can initialize a structure. First way is like a function call. Second way is by using key value mapping. And at last, you can initialize an empty struct and assign value to its members. Inside function create, the first way of defining a structure or initializing a structure is done via calling it like a function. To do stat dot push, name of the structure, opening parenthesis, here we have closing parenthesis, and the members of the structure. This is how you initialize the structure like a function call. Secondly, you can initialize the structure using key value mapping. Name of the structure, the first key of the structure which is text, the value which has been passed as a function argument, completed is by default set to false. This is how you initialize the structure using key value mapping. And at last, you can initialize an empty struct and then update it. This is how you initialize an empty struct. Type of the struct, memory location, name of the struct, then to-do.text equal to underscore text. Now this underscore text is nothing but the function argument. So what we have seen three ways of initializing a structure. First, calling it like a function. Second, using the key value mapping. And at last, initializing an empty struct and then updating its members. This is how you can initialize a struct inside Solidity. Going forward, let us look at how can we assign or access the members of the structures. The memory model to remember accessing members of the structure is structure name, then the dot parameter followed by the member of the structure. Example, let us take a look at this create function itself. Now inside this create function, here we have initialized the struct and this is how we are accessing its members. Similarly, if you have a look at the get function, inside get function, we are reading to-dos at index and storing that into to-do, and then at last we return the text value of that to-do and the completed value. So get is a public view function which returns string text and bool completed. This is how you access the members of the structure. How can you read a structure? The structure can be read in two different memory locations. First is you can read a structure into memory, and second is you can read a structure into storage. What is the difference of reading a structure into memory and reading a structure into storage? When you read a structure into memory, it is an explicit copy, whereas when you read a structure into storage, it is done by reference. What does this mean? Let us take a look at the update text function. Inside update text function, as you can see, the to-dos have been loaded directly into storage, and then we are directly updating todo.text is equal to underscore text, which has been passed as a function argument. Now this is possible because to-dos is directly loaded from storage and is referenced directly into the storage. When we say directly reference into the storage, that is, we are referencing it. Hence, when we do this statement todo.text, it is directly written back to the storage. Whereas if you could have loaded this into memory, then after updating the text value, there was a need to again write one more statement at the end, which would have been todos.index is equal to the to-do. This would have been the third statement if you could have used memory instead of storage. Because in case of memory, it is an explicit copy. In case of storage, it is done via reference. Going forward, let us look at how can we update a structure. Updating a structure is simple. The way or the manner in which you access the member of the structure. Similarly, struct name dot the member name is equal to value. This is how you update the structure. Once this is done, at last, there comes a question. Can we define a structure inside some another file and import that file into a specific file, and can we then reference or declare the structure? That is possible. First, we have our file1.sol. Inside this file, we have defined a structure todo, which has two members, text and completed. Then inside file2.sol, we import this file1.sol, and inside file2.sol, we are declaring a state variable of type todo. So this is possible. Let me just close this whiteboard, scroll down, and have a look at declaring and importing struct. Again, open the whiteboard. This is how it is done. Here we have files that the struct is declared in. Let us call this as file1.sol. Inside this, we have declared a struct todo. My bad, this file is called as struct declaration.sol. We have declared a struct todo inside struct declaration.sol. Then we have another file, and in that file we are importing struct declaration.sol. Inside this new file, you can declare an array of todo structs like this. This is possible because the type of todo is defined inside struct declaration.sol, which has two members, text, which is of type string, and completed, which is of type boolean. One important thing to remember is a structure cannot have its own type within itself. What does that mean? Inside struct todo, you cannot declare todo is equal to todo, because that would cause an infinite struct, or that would cause the size of the structure to be infinite. Hence, that is not allowed in Solidity. So let us just summarize what we have learned today. First thing, now we know what is a structure in Solidity. It is a custom user-defined type that can group several types together. Then we have seen how can we define or declare a struct. The memory model is use the keyword struct, name of the structure, followed by the members of the struct. How can you initialize a structure? There are three ways. First, like a function call. Second, using key value mapping. And at last, initialize an empty object and then assign the members of the struct. How can you access the members of the structure? Name of the structure followed by dot followed by the name of the member of the structure. The structure can be read into two different memory locations. First is memory and second is storage. When you read it into memory, it is done via an explicit copy. When you read it into storage, it is done via reference. How can you update a structure? Similar to accessing a structure name followed by dot followed by the member name is equal to the new value of the structure's member. And at last, we have seen declaring and importing structure. You can declare a structure into a different file, then import that file into a specific file and declare a state variable using the structures. And at last, one important point to remember is you cannot declare a struct inside itself, because that will cause the size of the structure to be infinite. So this is the limitation of structures in Solidity, that it cannot reference its own type. I hope I hope you have learned something valuable today. Thank you.